I wrote this book, Conifer Country, and it's a natural history and hiking guide to 35 conifers of the Klamath Mountain region. And I'm going to go into a little bit of the story behind why we have such unique conifers in the region. So first I'm going to answer the question, why did I even write a natural history book? And I wrote it because I feel like natural history tells the story of our living earth, and I think that's important. Why did I write a hiking book? Well, it was a good excuse for me to get out into the field. And I also think it's important to inspire others to get outside and reconnect with nature. So why did I write a book about conifers? Well, I think it's a manageable means to understand the biodiversity of the region. They're harbingers for climatic change over millions of years, so they've survived over deep time, and they tell a story in where they are now. We'll look at that story a little bit, and I think they're a gorgeous group of plants. So what is a conifer? Well, a conifer, they've been around for 425 million years or so. But if we step back right before the conifers, things like club mosses and horsetails, which we still have some of around here, and ferns, were the first to develop this vascular tissue that allowed them to go onto land and to grow upwards. But these plants reproduce with spores. So gymnosperms, which include the conifers, they came along soon after, and about 365 million years, and they evolved a seed. And then the angiosperms soon followed at 140 million years ago, and they also have a seed, but of course they produce a flower. And I'll talk a little bit about the difference and why that's important here in a second. So gymnosperms and angiosperms, like I said, they are the seed plants of the world. And the evolution of the seed helped to promote this dormancy. So the seeds could be stored a little bit longer. And that opened up pathways for distribution and also for evolution. So if we look at the difference between a seed and a flower, this is of course very basic, but gymnosperms seeds form on a variety of structures, and most like a cone that we're familiar with, but it remains naked. It's not protected within any sort of integument. Like an angiosperm, if you think about an apple's an exaggerated version, but angiosperm seeds are enclosed and they are formed by way of a flower.
What's a cedar?
That is a cypress,
Cypress,
which is very closely related to a cedar, and the taxonomy is debated currently still. So a little bit more about a conifer. The heyday of the conifers was about 250 million years ago, and there was as many as 20,000 species across the northern hemisphere and down into the southern hemisphere as well. And then 65 million years ago, there was an event. Most people now believe that there was an asteroid that hit and kind of changed the climate forever, and that allowed for the adaptive radiation of angiosperms. The planet warmed a little bit, and they were able to establish, especially around the tropics, and they began to co-evolve with certain animals, and that was the big leap. The flower with an insect or the flower with a mammal, and because of that, that promoted genetic variation, and it also promoted distribution across the landscape. And gymnosperms have concurrently declined. There's now only about 1,000 gymnosperms, and there's 300,000 species of angiosperms. So the flowering plants have exploded across the landscape, and gymnosperms have really become restricted, I guess, in many ways. And then this decline of gymnosperms and expansion of angiosperms is really one of the most important processes in the distribution of plants, the phytogeography, currently on Earth. So this was a big change. So a couple wow factors about conifers. They are exclusively wind pollinated, so they do not have any relationship to animals. Except for one African species, but it's not a conifer, it's a gymnosperm. So conifers exclusively wind pollinated. They do enlist animals to distribute their seeds, but it's not a large number of conifers that do that. They often grow where soil is suboptimal or climate. So they kind of hide out where the angiosperms don't do so well. They have these mycorrhizal relationships, so they've got these little fungi on their roots that help absorb nutrients and water. And not many angiosperms actually have that relationship, or not as many. One group that does are the orchids, and the orchids are like the conifers in that they grow on suboptimal sites quite often on poorer soils. And generally they're restricted to higher elevations and higher latitudes. The exception locally being our coastal forests. We're basically at the southern end of these conifer forests right here, and this is a real exception to the general rule. And this is kind of cool. Less than 1% of all plant species are conifers. It's actually, what, 1/3%? But yet they cover 30% of the Earth's forested surface. So even though there's only 1,000 left, they still do really darn well, especially in the northern hemisphere where you get north of the 45th parallel and they blanket the landscape. And also, all three of these are in California. The largest, tallest, and oldest living things are all conifers. So I think that's pretty cool. So this is a map of the diversity of gymnosperms per unit area. And if you look, I just think this is pretty cool because if you look around the Pacific Rim, half of all conifer species live along the Pacific. So we, of course, live in this little hot spot right here. But there's other hot spots, particularly in Japan, China, and Southeast Asian islands. The Sierra Madre of Mexico is renowned for its pines. But we are kind of at this area, this meeting ground, where we have bishop pine outside, which is a subtropical species, but we also have Cypress Spruce, which right at Casper Creek reaches the southern extent, and that's a temperate rainforest. So it's kind of a neat little meeting ground. So we're going to explore some of the conifers of the Klamath. But first I'd like to just kind of define the Klamath. Of course, we're right now a little bit south of the Klamath, but you can get to the Klamath, the southern tip at the Yola-Boles. And you can see that it extends all the way up into the Umpqua Valley. And this is defined by rock type. So, but there's the central continuity. There's the Cascades, the Sierra, the Coast Range, the desert, the Great Basin. They all sort of come together in the Klamath. So we have this this mixing of plant species, and it's a mosaic, like I just said. So we've got this crossroads of biota. There's also complex soils. This is just one example of that. The serpentine soils. Here in Mendocino, we have the podzolized. Did I say that right?
Yes.
Podzolized soils. And they kind of do the same thing. They sort of create these evolutionary microsites where plants, not a lot of plants do well there, but those that kind of sneak on and figure out how to survive turn into their own species over time. And that's true for certain conifers. It's actually even more true here, which is why I'm so excited to be here this weekend. So complex climatic conditions. So you see there's this with elevation. As you move inland, it gets drier, but with elevation, it remains wet. And there's also this gradient where it's really wet up north, but it begins to dry as you move to the south. So again, these interactions create these little mosaics of for plant survival. This is a diagram that I've created, and it's based on moving from Crescent City to Redding. And if you move across the Klamath Range, it dries out, like I said, but with elevation, you get these varieties of plants. So, of course, we're familiar with the coastal temperate rainforests with Cypress Spruce and Western Hemlock. Western Hemlock don't get into Mendocino County, but they get as far south as Ferndale. So they're pretty close.
Western Hemlock?
I'm sorry, Western Red Cedar.
Right.
Yeah, Western Hemlock do get south here. The Western Red Cedar end at Ferndale. But basically, we're here at the southern tip of the temperate coniferous forest. But as you move inland, things begin to change a little bit. In the Siskiyous, you get some Alaska cedars, which is the southern extent of their range. Port Orford cedars, which are an endemic. But then as you get into these drier areas, the pines become more common, pines like the dry sites. So this is just a little schematic to give you that idea of why we have such diversity here as well.
Oopsie.
So here's the Klamath Mountains that I've included in the book, from the Yola-Boles up to the Kalmiopsis Wilderness, and from the coast across to the Scott and Trinity Mountains. And I'm going to take you on a journey to a couple of these hikes. But one last emphasis here, there's 3,500 species of vascular plants in the Klamath. and 38 species of conifers. So it's a lot easier to I think, learn 38 versus 3,500. So those 38 kind of open that window into understanding all of this plant diversity. So this is my favorite conifer, and I'm going to start by showing you some pictures of what they look like. They grow in two spots. And these are the bristlecone pines, which are very closely related to our foxtail pines. But our foxtails grow in two spots. They grow in the Sierra Nevada, and they grow here in the Klamath Mountains. And then the Klamath, this is the Yola-Boles, and we'll take a peek there, but I'd like to show you what they look like in the southern Sierra Nevada. This is in Alta Peak in Sequoia National Park, and this is the Mineral King in the background. Coia River flowing down below. But they are the crowning jewels of the Sierra Nevada, at least the southern Sierra, I believe. And they kind of eke out an existence where not a lot of other plants survive. So in the Sierra, they basically survive by themselves. If we move into the Klamath, they begin to mix with a lot of other different species, which is interesting. So if we go to the Yola-Boles here, this is North Yola-Bole Peak. This is one of the hikes that I've highlighted in the book, and it's a nice short hike to get in, well, relatively short, about 3 miles to get in to North Yola-Bole Peak, where there's a really cool lookout at the top of, by the way. But there's also a highly restricted grove of foxtail pines, which is a pretty spectacular thing to see. They just survive right on top of the mountain, but they also survive with things like Shasta fir and Jeffrey pine. So there's a little bit more of a mixture with the plants here. This is in the Trinity Alps wilderness. These are the foxtail pines that are in the red trinities. And I like this picture because it shows how the serpentine kind of defines where plants can grow. So this is a south-facing serpentine slope. Not a lot of plants like it. The foxtails do. So they kind of hang out there. When you get out onto the north-facing granite, you're full of firs and hemlocks. So it's a little bit different scene, the north versus the south slope.
Red Trinities?
That's what I like to call them. Yeah. So
there's the blue Trinities to the west, and then there's the main Alps.
We call them. I like to call them the green, the white, and the red.
Ramshorn area?
So this is the Seven Lakes Loop. This is actually the flanks of 7 Up Peak right here.
Oh, okay. Right.
So,
Eastern.
Right.
Okay.
So coming in from the Trinity Lake area. This is a foxtail pine. This is Stewart's Fork down below. This is a foxtail pine I found a couple of summers ago. It's probably the largest one on the planet. I'd like to go back up there and measure it for sure. But
it's up above the Stewart Fork?
yeah. So this is right by right on the Seven Lakes Loop, actually.
Oh, okay.
Yeah.
I've done that many years ago.
Yeah, it's a beautiful hike.
Yeah.
And then this is in the north. This is an example where foxtail, they're not surviving on serpentine, they're surviving on marble. And this is actually Marble Mountain in the Marble Mountain Wilderness. And these are all foxtail pines. That's it on the summit. There's actually a couple of firs, but as soon as that marble gets really dense, it's just foxtails, which is pretty neat.
Is marble similarly, what is it, acidic, right?
Yeah, it's acidic and similarly restrictive.
Right.
There's several endemic plants. Well, there's a lot of endemic plants that survive on marble as well. There's just not as much marble as there is serpentine in our area. Okay, this is a cool story. This is the bishop pine, Pinus muricata. So 2 summers ago, I was able to go to the southernmost continental population. It actually grows out on a couple of islands as well. And here we are in Mendocino County, where we're basically at the northern extent of the range. But I went to this spot in Baja, Mexico, just to give you an idea what this habitat looks like. It's an arid grassland, basically. And these trees are really small and scrawny, surviving on this south-facing slope. If you look out the other direction, there's this dry riverbed. You know, we're on the edge of the desert. And of course, as we move north into our region, here's my corrected map, by the way, where Fort Bragg is the right spot. But they end just north of Fort Bragg, but then there's a population that's left up in Trinidad.
Right.
And of course, we all know, well, this is the northern extent, so this is the the hike that I've highlighted in the book to go see some bishop pine. There's not a whole lot left up there. A lot of them were logged. They were on private land. But there's still some nice examples. And of course here they're interacting. They're at the southern end of a rainforest. So this is another example of that deep time evolution. This is an ancient lineage of plants evolved in the subtropics, but it's been able to kind of hang on up here in the northern fringes because of the soils that it grows on.
It actually originated in the south, though.
Yeah, that's the theory.
Only remnant populations left.
Right. So things like
Really
it's closely related to the Monterey pine, which is of course,
Right.
well, now it's naturalized in the southern hemisphere.
Right.
It's the most common pine in the southern hemisphere now because of for forestry purposes.
Mhm.
But there were actually no pines south of the equator until they brought the Monterey pine south.
Mm.
But anyway, yeah, these are examples of very restricted plants.
Mm.
And here it is in the rainforest. Quite a different scene than in Baja at the southern extent of its range. So. Cypress Spruce, one of my favorites. I threw this in because we are at the southern extent of this species range right here. Literally steps from the bookstore. And you can see there's a nice gap here in the King Range where they disappear, but they show up again right here around Fort Bragg. And they don't really get further than a couple miles inland either, until you get up into Washington where they hug some of the big bays.
And are incredibly abundant up there.
And they are incredibly abundant. This is another neat story. This is still working itself out. There's actually a new paper just published about the local beach pines. But you can see that there's again a big gap. This is the Humboldt Bay area. But right in here, these are, they think there's actually two different either species or subspecies. There's the ones that grow right along the coast, and then there's the ones that grow on the staircases.
The bowling.
That they call in Bolander's pine. Some people say it's just a variety of the beach pine, but it looks like it may actually be its own subspecies.
They sure act completely differently.
Yeah, I think
they're
they do
not,
as well.
They don't seem to be the same thing. Just like it doesn't seem to be anything like a lodgepole.
Right. Oh, I know. It's way, and
What
it's funny that
a chameleon.
they have this species named contorta, because when you get inland, they're as straight as they can be. So along the coast, they're contorted by the wind. This is the only place here in Del Norte County, also in the Kalamiopsis, where the beach pine sort of meet the Sierra lodgepole pine, so to speak. And this is a zone of hybridization that I refer to as the Del Norte mystery, because they're not quite sure. I think it's just a hybrid zone. But the cones are somewhat similar to the coast, but it's just a weird little area of interaction there.
If you talk to the local naturalists, you'll really find a lot of information about how much variation there is between Bolander and beach pine in this area.
Yeah. So this is the last hike that I'll talk about. This is a hike to the Devil's Punch Bowl in the Siskiyou Wilderness. And this is an exceptional hike because you can see 16 conifers on this trail, which is pretty much the most diversity you'll see anywhere in the world. There's actually one spot in the Russian wilderness you can see 17 species in 1 square mile. But in this 5-mile hike you can see 16 species, which is pretty exceptional. And if we zoom in and look at a couple pictures of the Brewer Spruce, this is of course the cover shot. But they also enjoy the serpentine, the edge of the forest, sort of the poorer sites. And I didn't really emphasize that. Put the range map. Yeah. So if we look at the range map, this is the only place in the world that this tree lives. It used to get as far west as Nevada, up into Oregon from the fossil records, but it's sort of contracted and restricted back into the Klamath Mountains, just in these little pockets, and most extensive through the Siskiyous. So we'll just look at a few pictures here. This is in the Trinity Alps. Just kind of wanted to end with some highlights of the Brewer Spruce. Marble Mountains. Back in the Trinities, the big granite. This is in the fire of 2008 up in Siskiyous. It's got this nice pendulous drooping form, really makes it stand out from a distance. Preston Peak in the background, one of my favorite mountains. Back in the Trinities near Canyon Creek Lakes. Pretty distinctive cone. These bracts are a little bit firmer than the papery bracts we're used to seeing on the Cypress Spruce right here on the coast. This is interesting. This is Brewer Spruce regenerating after a fire with the knobcone pine, which is a close relative of the bishop pine. And a lot of scientists say that the Brewer Spruce has been chased out of areas that have seen fire. This is evidence that they may actually deal okay with fire. Here's again in the Siskiyou Wilderness near the Devil's Punch Bowl. This is on top of Preston Peak, looking out towards the ocean. This is Broken Rib, and here's the Pacific Ocean right here. Whoops, it's in there twice. These are some nice pictures of the pollen cones. This is the Devil's Punch Bowl, pretty much the most popular hike in the Siskiyou Mountains. And there I am parting the branches of the Brewer Spruce, which I refer to in my book as entering Narnia. I really think that that's just an absolutely spectacular and special tree. So. And this is the largest Brewer Spruce on the planet. I've never seen anything anywhere near the size of this tree, but it's 140 feet tall, and the DBH is something like, oh, I measured, I think it's like 20 feet, 21 feet around. So, pretty spectacular tree.
Where is that?
That's up Canyon Creek, actually.
Is it?
Yeah.
Uh-huh.
Near the upper lake.
There's some big ones in the Ramshorn, east of the Trinities, the eastern Trinities?
Yeah.
East of the lake?
Yeah.
But not that big.
Right. I've driven that road.
But there's some beautiful pockets of trees back, tucked away. We timber cruised up there for years.
So, I just wanted to throw in the pygmy cypress, because that's a special tree right here around Fort Bragg down into Sonoma County. I forget the name of this park, I haven't actually been there. But this is a plate from my next book that will come out next year, but it's going to be all the conifers of California, Oregon, and Washington. So,
well, that's another taxonomic debate.
It is a taxonomic debate, but I've read, there's actually 2 new papers that have come out, and they all say
it is a separate species?
It's not Gaviniana.
So Mendocino cypress is a separate species than pygmy cypress?
Well, okay. I'm giving it the common name pygmy. You could call it Mendocino pygmy or Mendocino
cypress.
See,
I was familiar with it first as a pygmy species, and then I went timber cruising and I found Mendocino cypress that were 150 feet tall.
That's one of the tallest trees off the soils.
And they were abundant and thriving. Yeah. They weren't like struggling. They were happy in this little watershed.
So that may be why
Jackson State Forest.
Maybe why I should drop pygmy as a common name and just call it Mendocino cypress, because there are exceptions.
Yeah, I think it's more appropriate because it's different pockets unless you can prove that it's a different species, but it seems exactly the same. Yeah. From everything I've ever seen.
So they've decided in this new DNA testing that these are its own species. Then you have the Santa Cruz cypress in the Santa Cruz Mountains, and then you have the Gowan cypress right on the Monterey Peninsula. Those are the 3 little populations that they thought might all be one species, but they've sorted them out. So I think it's a pretty convincing argument. So anyway, the pygmy cypress will be in this next book, Conifers of the Pacific Slope, which I'm working hard on right now. But this is the book that I currently have. And I thank Gallery for hosting, and for y'all to come out and check it out. So anyway, are there any questions? I know Bob's been throwing stuff out, which is great, but does anybody have any questions about the world of conifers in Mendocino County?
As I was flipping through the book, I was finding some things that were contradicting things that I've read elsewhere, but I couldn't remember where I read them elsewhere. But it was about the paleontology of our coastal redwoods. You were saying that plant community is a quite recent thing in paleontological terms.
The climax part of it, especially.
Yeah.
I'm fascinated by that too.
I was trying to remember where I'd read that in eastern Oregon there are fossils of a very similar association from the very similar pines and all the ferns and so forth, going farther back than that.
Well, I think what I know what you're. I mean, basically, there's 3 places on Earth that you can see forests that are, say, 80 million years old. One of them's a redwood forest. One of them's the Alerce forest in Chile, and the third is on New Caledonia in the South Pacific. So these 3 places basically mimic what it looked like before the Tertiary began, which was after the asteroid hit. So in that respect, yeah, this is we are seeing an extremely ancient forest. But the argument that scientists are making that have studied the redwood forest is that it's such a dynamic forest in itself, and it's so old that when you talk about generations and the redwood's interaction with other plants, you're talking about these really, you're talking about one generation could be, say, 2,000 years, right? Or 1,000 years. Now, let's just say it's 1,000 years. So their argument is that we're only seeing these forests that are 5 generations old.
Yeah.
So 5,000 years old, because they change, they just move around. I mean, 20,000 years ago they were in Santa Barbara. So there's obviously this migration that's happening because of climatic change.
Is there any way to tell if that 1,000-year-old tree is a stump sprout from a 1,000-year-old tree?
That's the other question. Yeah, I think the answer is probably not. But if you look at least patterns in growth, I mean, you've seen the fairy rings of redwood trees, especially even with some old growth. So you know that was that's exhibiting that sort of behavior. So that's what I was trying to get at with saying that in the redwood tree was. It's just such a dynamic forest, but yet the generations last so long, and it must be changing.
And when you think about all the canopy research that's being done, and mushrooms and salamanders that never touch the earth, and the murrelets, and just all the complexity of life up there, and the mosses and ferns and everything, it's just amazing. And yes, it was perhaps there 10 or 50,000 years ago, or maybe even a million, but it's evolving into a more elaborate thing as long as the climate allows it to.
Right. And the difference between redwoods in the north and redwoods in the south is stark.
Yeah.
No, sure.
So I think that's the other argument, is things are sort of drying up and contracting into canyons in the south, whereas from here north we're still kind of in that really lush forest. That's what it may have looked like further south.
Which brings to mind another question from the same section, where you're talking about expanding hypothetically expanding the redwood range to the north. And there was the barrier of serpentine there. I was wondering, our little dog picks up redwood branchlets and carries them around a lot. It would seem like critters could be carrying the branchlets with the cones for quite a ways.
No, I agree, and I think there's a weakness in that argument, in that there's also that warmth that's required for redwoods in the summer, and that's sort of the transition into the really wet, longer periods of wet, and less of this California climate that we're used to. So I think that's another, and I actually changed that a little bit in the second printing. Because I was challenged on that from somebody in Oregon who said, I think you're half right. So I added in a little bit more about the climatic restrictions.
That's the beauty of Michael's cutting edge presentation, is that it's still evolving and being discussed, and he's responding to that. And let me tell you, I'm mightily impressed by this book, even though I haven't read it cover to cover.
It's hard to read from cover to cover.
Information is in depth. I have read almost all of the hikes, and I love what you've done there. It's like not too much is revealed, but a reason to go is always revealed. And, some wonderful things there, since I've done about half of them.
Great. Well, thanks. I appreciate y'all coming and listening. Yeah.
If we get a chance to travel, where in the Siskiyous is Devil's Punch Bowl?
Devil's Punch Bowl is up out of Gasky, so if you take 199 out of Crescent City, east, well, it's sort of northeast, I guess.
Yeah.
And you go about an hour, I guess. Maybe it's 45 minutes.
Kind of at the
and you know Patrick's, you get up past Patrick's Creek Lodge.
Yeah, yeah.
And it's, I think, the next right after Patrick's Creek, about 5 miles. It's called Little Jones Creek.
Okay.
So it's written up well in the book.
Okay.
But it's just a stellar destination.
Yeah, it sounds like it.
Great swimming. Don't recommend camping there.
Okay.
Because there's a lot of people that do.
Yeah.
They're going to try to ban fires in the area because there were some Alaska cedars that got cut down this summer for firewood.
Ah.
Yeah, which is one of our rarest trees.
Right.
Yeah, right.
And you can't even burn it. You know, you cut it down, you're not going to burn it that night. So that's
bummer.
Anyway. So Forest Service is working to sort of limit access, or not
That's
access, but limit usage up there. But it's a great.
Sounds great.
Yeah.
Yeah. Very cool.
So yeah. Well, cool. Well, thank you very much.
Thanks for coming.
Yeah, appreciate it.